Alright, now we're going to look at the rest of the function operations that we can work with. We're going to use the same charts we used from addition to answer some more questions. So for example, 3, we're going to do what is f of 1 minus g of negative 1? Well, let's look at the chart. Here's f of 1 down here, negative 1, right? And g of negative 1 is 2. So we're just going to replace them with what they are in the chart. F of 1 will be replaced with negative 1. G of negative 1 will be replaced with 2. Okay, those are just y values that come straight from the chart. So now we have negative 1 minus 2, which equals negative 3. Therefore, f of 1 minus g of negative 1 is equal to negative 3. So always reference the chart when you're asking function operation questions that are numeric in nature. Now we have a general question of what is g minus f. In other words, what is g of x minus f of x? We don't know what the inputs are, so we have to ultimately look at the entire chart. I've said this before, the x values must be the same, but ultimately f minus g just means take the y value of f of x and subtract the y values of g of x to get a new set of y values given the same x values. So that's what we're going to do. We're going to take the, oh, was it g minus f? I'm sorry. Well, f minus g would be the y values of f minus the y values of g, but it's g minus f, so it's going to be the reverse. It's going to be these values minus these values, so going in this direction. Like I said, you can do it either way. Okay, so take the y values of g, subtract the y values of f, and notice the x values stay the same. You're just subtracting the y values to get a new set of y values, and they are 1, 1, 0, negative 1, negative 1. These would give you new points on a graph, by the way. Same x values, different y values. So when it's a generic g minus f, no inputs stipulated, then you need to subtract the whole chart. Okay, let's move on to multiplication. We have f of negative 2 times g of negative 2. Now again, there is another way to notate that, and that's by putting f times g of negative 2. It means the same thing as f of negative 2 times g of negative 2. It looks weird, you're just going to have to get used to it. So let's take a look and see what that looks like. f of negative 2 times g of negative 2. Well, here's f of negative 2, it's 3, right? And g of negative 2 is 4, so you're literally just going to be multiplying these two y values, 3 times 4. So replace f of negative 2 with 3 and g of negative 2 with 4, and voila, you get 12. So f of negative 2 times g of negative 2 is equal to 12. Very simple. Now in general, what is f times g? You need to multiply the entire set of y values. So not just f of negative 2 times g, not just f of negative 2 times g of negative 2, but the entire set of y values. So you're going to take all the y values of f and multiply all the y values of g, and again, we can do that because they share exactly the same x values. You can only do that with two of the same x values. In other words, we can't take the y value from 0 and multiply by the y value of negative 4. It wouldn't make any sense. They have to correspond. Okay, so let's go ahead and do that. We're going to take the y values of f and multiply by the y values of g. Same x values, we're going to get a new set of y values. 3 times 4 is 12, 1 times 2 is 2, so on and so forth. This chart right here, again, when you have a generic f times g or f minus g or whatever, and there's no input stipulated, your final answer is your entire chart. So this chart gives you f times g. Next up, we're going to be doing division. It's going to be f of 0 divided by g of a. Now, this is stipulating that a can't be equal to 0. So what does g of a actually mean? Well, g of a is going to be just some, basically it's going to be all of the x values except for 0, right? Some arbitrary a. So f of 0 divided by g of a. Well, this is weird. What is f of 0? F of 0 is 0. So we're going to take this y value, right, and we're going to divide by all the y values that come from something other than 0. So we're going to be dividing 0 divided by 4, 0 divided by 2, 0 divided by -2, 0 divided by -4. Well, you're going to get 0 no matter what, right? So in essence, that's really what this question is getting at. F of 0 is always 0. So as long as you're not dividing by 0, you're going to get 0 back. A little tricky, but that's all right. So f of 0 is 0. G of a is just g of a. As long as it's not 0, it's a non-zero number, right? You're going to get 0 back. And that's going to be our answer here. That's function division. All right, next up we have in general, what is g divided by f? And I meant to notate this in a different way. Okay, you might also see it this way, g divided by f of x, or g. You also might see it notated this way, g over f of x. They mean g divided by f. Again, it's just a more succinct way of writing it. I don't really like it that way. I'd rather just be straightforward and say g divided by f. Note that f divided by g is not the same as g divided by f. Commutative property doesn't work for division. But what we're going to do here is take all the y values of g and divide by all the y values of f to get a new chart. So we're going to take all these y values and divide by all these y values. Again, we can only do that when the x values are the same. So we're going to take 4, 2, 0, -2, -4, all the y values of g, and divide by all the y values of f. Notice that 0 over 0 is undefined, but every other set of numbers gives you some number back. And just leave it in fraction form because that would be a repeating decimal. And again, when it's generic like this, your final answer is just going to be a chart. It's not going to be anything more complicated than that. This is a generic g divided by f. Had it said g divided by f of -2, right? Then your answer would just be 4/3, but we have to do every single y value in the column. That's going to be it for this video of multiplication, subtraction, and division function operations. If you have any other questions about this, let me know.